Hi class, this is a video that's introducing you to heat calculations. So the formula we're going to be using in this video is Q equals mc delta T. We're really not going to focus too much on calculations with this formula. I more just want to prepare you to solve problems with it by being familiar with the units and with these symbols. Okay, so we've got our variable symbols over here. Q, M, C, and delta T. That's what's in our formula. Q equals MC delta T. Then we've got a description for what each one is. And then we've got the units. Now remember, units are things like grams, liters, milliliters. The symbol or the quantity would be something like mass or volume. It describes it, but it's not the unit. Okay? So if I say mass, or M, mass, the units for mass are grams. You can see that right here. Mass is units of grams, right? G. But some that you're not as familiar with might be like heat. Q represents either heat or energy that's absorbed or released in a reaction or in any other process. Joules are the unit that we're going to use for that. Then we have this thing called specific heat. You probably haven't heard of that before. Maybe you have, but you might not be as familiar with it. Specific heat is represented by the lowercase letter c. It is units of joules per gram degree Celsius. And then we have delta T. As you could maybe guess, T stands for temperature. That delta just means change. So delta T means the change in temperature. It's the final minus the initial temperature. That's really important to recognize. It's what you end with minus what you started with. That tells you how much the change was. Whether it increased, that would be a positive delta T, or whether it decreased, that would be a negative delta T. And the units of delta T, or temperature in general, are going to be degrees Celsius. Let's look down here a little bit farther. Okay, if heat is absorbed by the system, and if you've watched the endothermic exothermic video already, you kind of know this. Maybe you'll kind of know what this means. But if heat is absorbed by the system, the process is called endothermic. Need to put a little more space there. Actually, let me just rewrite that because that's really sloppy because it's super small. Endothermic. Okay, if the heat released by the system, the process is called exothermic. Okay. If it's absorbed, it's endothermic. If it's released, it's exothermic. But what I want you to know is the sign for it. The sign for Q, if it's endothermic, is going to be positive, and the sign for delta T will also be positive. If it's exothermic, the sign for Q is going to be negative because it's releasing, it's giving away the heat. The sign for delta T will also be negative. Okay. So let's do a little bit of practice with this. What we're practicing here is identifying the variables. So let's work on that. We want to label them as either Q, M, C, or delta T. So we want to match up the variable letter with the units. The number really doesn't matter that much. We're focused on the units. So when I see J, that means joules. Joules are units of heat. So I'm going to put Q. 0.9873, but the units are joules per gram degree Celsius. What's that a unit of? Specific heat. Okay, and I'll go through the rest of these a little bit faster. 3.75 degrees Celsius. That's delta T. 0.0458 degrees Celsius. Again, delta T. 0.0458 joules per gram degree Celsius. It's our compound unit for C. 1.03 grams. That's mass. 0.0458 grams. That's mass. And 0.0458 joules is Q for heat or energy. Okay, I'm going to do just one of these, this practice problem at the bottom. We're going to label the variables. That's the first part. The most important part for you to get from this video is that part. And then we're also going to use the equation Q equals MC delta T to solve the equation for the unknown variable, whatever the unknown is. So let's go through this. I've got grams, that would be mass. This is Q. This is delta T. So if I have my equation Q equals MC delta T, I have Q, I have mass, I have delta T, C is what I don't have, right? So C is what I'm looking for. All right, now I could solve for my problem. Mass, well, let's do this way. Q equals MC delta T. Q is negative 4,600. Q equals, and then mass is 25, times C. That's my unknown, so I'm going to put C. And then delta T, negative 35. Okay, these are all being multiplied, so I need to simplify this by doing 25 times negative 35. I get negative 875 C. On the right side. And then over here, I still have negative 4,600. If I want to solve for that, I want to get C by itself, just like if I was solving for X. Right now, these two values are being multiplied. I need to do the opposite. I'm going to divide. Okay, so C equals negative 4,600 divided by negative 875. Okay, and we're going to round to two significant figures because that's the lowest number of significant figures. So if I do negative 4,600 divided by negative 875, I get 5.25, so on. Okay, I want to round that to two significant figures, so instead of 5.25, I'm going to put 5.3. And my units are, well, I'm looking for specific heat. My units are going to be joules per gram degree Celsius. And that's my final answer. Okay, make sure you're at least comfortable with this section up here. And this part right here. We're going to spend a little bit more time with the calculations, but you need to be really comfortable identifying the variables before we can move on to the next step.